turning revolving center. To create this, so we have a diameter 22 to a length of 32, and then we have 20.4 at this end, and we don't know what is the length of this, diameter of this, but we have 50 mm, but it has a taper of 1:20. So to have a taper of 1:20, that means for every 20 mm length, there will be a decrease in 1 mm diameter. So that is, if it is 50 mm, then it will be 2.5 mm decrease in the diameter. So that means 20.4 minus 2.5. So that is the value. So 17.9. 20.4 minus 2.5 will be equal to 17.9. So that divided by 2 will going to give you 8.95. So this is how you will be able to get this. So now we will going to do the problem. So to do this model, you just go to new, click on ISO metric part, then click on ordered, and then hide this UCS icon, hide, then come down to enable the base reference plane. Now we'll go for home, click on sketch. So click on the coincident plane as the front plane. Now we will going to take up the reference. So the reference what we are considering at this point now. We have this point as the reference. So now from here you take 32. So go to project to sketch. You just click on this and click on this. So now he says it is 22. So offset, you take the distance as 11 mm. So take it as 11. Take it as 11. You just click on this. Then again come down to this diameter, which is, length is 32. Offset. Take 32. That means the length itself is 32. You just click on this. So go to trim corner between these two, between these two, between these two, between these two. Now in this we have, at this end we have a 20.4. So that means 10.2. So we're going to consider that. So go to offset, take the distance as 10.2. So from here you take this 10.2. Then we have a overall length which is of 50 mm. So you take offset, take the distance as 50 mm. So you select this and take it out. Then from go to trim corner between these two, you select this. Then again you have a 50 mm. So taper 1:20. So the taper 1:20 means, so it is 1 divided by 20, which will be equal to 0.05 into the length is 50. So that will be equal to 2.5. So first end diameter is 20.4. So I'm going to take 20.4 minus 2.5, which will give you the 17.9. This end diameter is 17.9, but since we want the radius, it will going to give divided by 2, it will going to be 8.95. So go to offset, and take it as 8.95. So you select 8.95, and then from here you take this, then go to zoom area, and then go to line, take the end point of this to end point of this. Then go to select on this line and remove this and remove this. So go to trim this portion and this portion. So now we have the cross section. Now we're going to take fit. So then we have the revolving center. So the revolving center will be 60, that is to the horizontal, to this you have total distance is 60 degrees, but we have 30 degree for half. So this side is 30. So naturally this side will be 60. So 90 plus 60 means minus 150. So I'm going to draw a line, take end point of this. I will take somewhere around 100, angle minus 150. So we are going to get to the vertical, to the horizontal. The angle will be 30 degrees on one half. In the other half, it will be 30 degrees. In other half, it will going to be 60. Total will be 60 degrees. Now you'll just go to the trim corner between these two. Now you go to delete this line. So then it becomes the surface. Now we have the one half. So we are going to have the close sketch. Then go to home, click on home, click on revolve protrusion. So just click on this, accept it, click on the axis, revolve it through 360 degrees. So this will going to be the revolving center. Now we want to save this. To save this, we have a center. So this is the 19th part. Now that is cast steel. Now we'll just go to application button. So come down to material table, come down to cast steel, click on this and say apply to model. Then similarly, you just go to this again, application button, go to info, click on file properties, click on summary, type center, CENTRE, center, click on OK, and now we're going to save this and type CENTRE, center, and say save. So this is how you will be able to create the model. So this completes this part modeling of tail stock.